Chapter 1.6, Representing Functions as Rules and Tables. Functions consist of inputs or domains and outputs or ranges. Functions have many different forms, but one of them is where you have f of x, meaning a function of x, is equal to 2x, so 2 times x. This can also be written as y equals 2x, and that's probably the form you see it in more often. Your x value is your input, and these are your domains, and your y value are your outputs or ranges. Inputs and domains can also be referred to as the independent variable. And your outputs and ranges can be called your dependent variable. This is because whatever you put in for x affects what you put in for y. So x is independent because you choose what goes in there, and y is dependent because it depends on what the x value is. One example of inputs and outputs would be pumping gas at a gas station. So here, your input, like we said here, your input is x, so this is going to be x, and your output is y. So y, the dependent variable, is going to depend on x. So if you go to the gas station, you may get 10 gallons of gas. So this would be how much gas you get. And if you get 10 gallons of gas, and each gallon of gas costs $2, so 1 gallon equals $2, then you would pay $20. So this would be the cost. If you input 12 gallons of gas, it would cost you $24, because for every gallon of gas you would pay $2, so 12 times 2 would be 24. If you were to put 13 gallons of gas, it would cost you 13 gallons times $2, which is 26. If you were to get 17 gallons of gas, that would cost you $34. So this chart here is actually a table version of y equals 2x. So if we take this 10 here and we put it in for x, we say y equals 2 times x, and x here is 10. That's going to give you 20. And that's what we have here. Because you're choosing how much gas you want to put in your car, that makes the input the independent variable. A quick memory trick for remembering inputs and domains and outputs and ranges are that I and D come before O and R. So inputs and outputs go together, and domains and ranges go together, and the input or the domain is always the first one, and that has the earlier letter in the alphabet. In your homework, you're going to be asked whether or not something is a function. Functions may be represented by mapping diagrams. Mapping diagrams show the inputs and outputs of a function. So I is for input and O is for output. So one thing to notice is that an output may be paired with more than one input. So here you have 2, which is an output, and you get 2 if you put a 3 or a 4 into the function as an input. However, no input can be paired with more than one output. So you have 0 here as an input, and you also have 0 as an input also gives you 3 as an output. So that means that this is a function, and because this can't happen, you can't have 2 outputs for one input, this is not a function. So that's something to look for when you're trying to decide whether or not it's a function. Now look at these table representations. Pause the video and guess whether or not they're functions or not functions. If you guessed function for this first one, you're correct. And if you guessed not a function for the second one, you're also correct. In this first one, you have 2 inputs with the same output. That's okay. For the second one, you have the same input that gives you different output. That is not okay for the function, and so that is not a function. Also note that here we have inputs and outputs in domain and ranges. Inputs are the same thing as domain, and outputs are the same thing as range. You'll also be told to make a table for your function. So I'm going to change this and make it y equals 2x plus 1, since we already did y equals 2x. So go ahead and make a table for y equals 2x plus 1 using the domain 0, 2, 5, 7, and 8. So y equals 2x plus 1. To set up your table, you should have domain and range, just like the ones we've seen before, and like this one you see below. Then you want to list your domains across like this. So your domains are 0, 2, 5, 7, and 8, as given right here. And whenever you see domains, you should put a bracket around them. Sometimes the book won't, but I would like you to do it. So to solve for the range, ranges, remember, are like your y's, and domains are like your x's. So you're going to say y equals 2x plus 1, and then you'll substitute your domains in for x. So you'll say y equals 2 times the first one, let's say 0 plus 1. So that becomes 2 times 0, which is 0, plus 1, which is 1. So y equals 0 plus 1, y equals 1. That is your range for that value. For the next one, you do the same thing. So you take 2 and you'll plug that in for y. So you say y equals 2 times x, which is your domain, so 2 plus 1. 2 times 2 is 4, plus 1 would give you 5, so y equals 5. And you put that in your range. So you keep going through. So this one becomes 5, so you plug 5 in for x. So it's 2 times 5, which is 10, plus 1 is 11. And then you have 7. You can work these out on your own paper. 7 times 2 for this part here is 14, plus 1 is 15. And 8 times 2 is 16, plus 1 would give you 17. And you're done. For the next type of question, you'll see write a rule for your function. A rule is the same as saying write an equation. So we're going to say that our range will be y and our domain is x. So we're going to have y equals something that when you have an x in it and you substitute the domain in for x, you'll get the y value. So for the first one, we know that y equals 2, so we can put that there. And we know that the x value, which is 0, has to be somewhere on the right side. So how do we get a 2 to equal 2? Well, we could do 0 plus 2. And that would give us 2 equals 2. So if we were to use that as a rule, we would say y equals x plus 2. And that would look like what we have here. So our 2 would go here for y. Then we would have x, which is 0, and we would add 2 to it. So let's test that out with some of these other ones. Y equals x plus 2. For the second one, our x value is 1, so 1 plus 2 should give us this value here, which is our range. That's our y value, and this should be 3. 3 equals 1 plus 2, which is 3, so that's true. So now let's try it with the next one. So let's start again with our equation that we made. So y equals x plus 2. Our y value here is 6, and that's equal to our x value, which is 4, plus 2. 6 equals 6. Correct. So far, this rule, or this equation that we created, seems like it's correct. So go ahead really quick and check the others. So if you have 6, which is our x value, plus 2, you get 8. That's correct. If you have 10 plus 2, you equal 12. Great work. So we solved for a rule, and our rule is y equals x plus 2.